There it goes. Okay, so we're recording. Now, your do now, I hope that you've already downloaded it while we were doing our mood meter stuff. If you haven't, then take this time now to make sure that you're downloading the do now and the guided practice. Today is Thursday, the 10th. The objective for today is to talk about primary and secondary succession. And other important thing. Oh, you know what? I'm going to go ahead and tell you this now. I decided I messed with the idea yesterday and I thought more about it, and I think the more I think about it, the more I like it. I'm going to go ahead and stop giving our weekly quizzes because now that we're doing the exit tickets a lot more standardized and every day, I figured that's probably more than enough as opposed to having to give you another thing on top of that. So for the time being, don't worry about any of our our weekly quizzes. We'll just continue doing our exit tickets the way that we're doing them. And then exams, of course, will be a whole different thing. But I figured that you didn't need the added stress of weekly exit tickets plus quizzes plus tests. So I took the weekly quizzes out because we do have to do the exit tickets every day. So it's a little bit less. Hopefully it helps a little bit. But I think that's the most important thing. We still have our CK through 12 readings. I still might put those CK through 12 stuff on tests or on pop quizzes if I feel like nobody is reading. But that's just a thing if no one's reading. So hopefully it won't come to that. Okay, let's jump in. So our objective, actually we're going to do our do now first. So our do now is posted in the assignments. So go ahead and work on that. I'm going to give you all a little less than 10 minutes to work on it. There's some reading, some questions. After the 10 minutes, we're going to talk about it. So here we go. Oh, I'm sorry, Josiah. I think I heard earlier that the solution was to exit out and then come back in. Clinton Brighton, I definitely agree with you. This is probably more information than what you need, but Raymond is actually my legal name. But when I was growing up, I demanded that everybody call me Rex. So I had seen Jurassic Park, and I really liked it. I wanted to be a paleontologist. So when I was like, 8 or 9 years old, I wanted everybody to call me Rex. Actually, I might even be younger than that. When did it come out? Like 93, 94? Maybe even 6. So I've gone by Rex since I was a little kid. Raymond is my real name. I'm Raymond Jr. But Rex is the name I've gone by for a while.
Raymond.
Mm-hmm.
And this is brainstorm. I know what brainstorm is, but do we actually put our answer for number four also?
Mm-hmm. Thank you, Miguel. I guess I should clarify. I don't necessarily want the answers in the chat, but thank you for doing that. You're right, here you go. That's where you're supposed to put them. We're still working about 2 minutes left. About 1 more minute. Make sure you're wrapping up your responses. Thank you for writing in complete sentences. Okay, and that is time. Does any brave soul want to come off mute and tell us what their answers are?
I can tell you what number one is.
Go for it.
Um, is it?
Oh,
Come on, come on. Hurry up. Okay. All right. Is it coal-fire power plants?
I like the way you're thinking, but I think I would need a little bit more for that. Does anybody else want to answer that one?
can I try?
Go for it.
I said that burning fossil fuels can affect the nitrogen cycle by putting nitrogen oxides into the atmosphere, which causes smog and acid rain.
That's perfect. That's exactly what I was looking for. So, the reason I wanted to have you guys do this is because when you think of pollution and stuff, I didn't want you to think that it was just carbon from the carbon cycle. It's also nitrogen. That's why we're talking about both of them. So when we're talking about like acid rain and ammonia in the air and also all the runoff from like coal factories, it's all kind of connected. They're all contributing to this negative thing. So thank you, Casey. Anybody else want to go for number two?
Sure,
Go for it.
I could do it. I said, like it says, number two says, what are the consequences of burning excessive amount of fossil fuels? I said they could cause many types of pollution, smog, and acid rain.
Thank you, Grace. Excellent. Very good. Anybody else for number three?
I can.
Go for it. Is that Brighton?
Oh, so in this cycle it comes from pollution and I forgot the word, but it's from animals, like yeah, and plants.
Yeah, good. And we're actually going to talk more about that in a little bit. So thank you. I'm glad you're thinking that way. Anybody want to volunteer the possible solutions?
I can volunteer.
Go for it.
I can some of the possible ways we can like plant more trees. We can use like carbon free cars.
Yeah,
Yeah.
those are both good solutions. Okay, very good. So I wanted to make sure that the nitrogen cycle was still fresh because I want us to start practicing looking at this cycle again. Because again, I don't want you to forget this. It's important to remember it. So this is going to be a guided practice. So unlike our independent practice, I'm going to actually go through a lot of these with you. So since you have your do now, that means you also have your cycle practice. So go ahead and pull that out. And I'm going to walk through this one with you guys as well. So number one, based on the diagram, what two ways does carbon leave the atmosphere? So when you're looking at this, what I want you to do is to look at the direction of the arrows. So here we have our carbon dioxide. How is it leaving the atmosphere? So we've got an arrow going down this way, another arrow going down this way. Anybody want to say what they think is happening with these two arrows?
Wait, can you repeat which two arrows?
Yeah, so we have our carbon dioxide in the atmosphere right here. So the two arrows pointing away from it, we got one blue one green one. What do they represent?
Oh, I know.
Okay.
Oh, I'll let Casey go. Never mind.
No, Hugo can do it.
All right, I'll just say it because I know the answer. It means like the plants are taking in the carbon dioxide, which means they need the carbon dioxide, which also
Very good.
shows that the ocean also needs it. That's the transfer of energy, right?
Very good. Yeah. So there's carbon dioxide in the air that we're breathing out, right? What happens is the plants breathe that in during photosynthesis to make sugar. And then the big part of that is also dissolved in the ocean. Excellent. Number two, based on the diagram, what two ways does carbon enter the atmosphere? So we got leaving earlier. Now we're looking at going in. So there's one arrow here with pollution, like we just talked about during our warm up. And you can also see down here respiration. So earlier we talked about how how animals breathe out carbon dioxide, right? Plants breathe it in to make the sugar, then we breathe it out because for us it's a waste product. So those are two sources of carbon entering the atmosphere. Number three, based on the diagram, how do animals get carbon in their bodies? Very easy. Right here, you see it. Here's animals, and they're getting it through feeding. If you remember, the plant's taking in that carbon dioxide to convert it to something usable, which is sugar. So that is a form of carbon, which is then going to be eaten by animals. So how do they get it in their bodies? They eat it. Number 4, based on the diagram, how do plants get carbon into their body? I'm sorry, how do plants get carbon into their body? We just talked about it. I think Hugo said it earlier, right? Carbon is taken out of the atmosphere and then taken inside the plant. So check your answers. The ocean sedimentation is pretty specific. That's what happens later after the carbon has been dissolved into the water. That's not going to be on the star. I wouldn't expect it to be. But it is based off this diagram. Pollution, respiration, feeding, and of course, photosynthesis. So I'll give you all one more second to finish that up. Now, we're not going to do every single question. I just wanted to hit the highlights, make sure that we're all on the same page. That way, when it comes time for you to work, you're not going to have as much to do. Okay. So for example, a lot of these I want to skip. But number 5, what is the job of decomposers in this diagram? So you find the decomposers, which are right here. What are the decomposers doing in the diagram?
Well, aren't they just explaining the difference between animals and plants?
They're not really explaining anything, but they are doing something to the animals and plants.
Are they like decreasing? Decreasing?
They're close. They're D something. What's this word?
They're decomposing animals.
Thank you, Eileen. Yeah, so what they're doing is they are breaking down the animal and the plant. Like after they've died or if they've lost water or whatever, they are breaking down those components into individual carbon atoms. They're decomposing it. They're breaking it apart. Over time, those animals can turn into fossils, which is just a trapped version of that carbon. Like the video the other day showed you how there's more carbon trapped in rocks than there is in all the liquid petroleum in the world. So it's really just carbon. The bacteria is extracting it, trying to make it usable, and then returning it to the soil. Okay. Blah, blah, blah. Y'all can do that one. Y'all can do that one. Blah, 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 blah. Yeah. So moving on down to this one. So the top one was dealing with the carbon cycle. This is dealing with the nitrogen cycle. Who is responsible for most of the nitrogen cycle? Super easy question.
Is it bacteria?
It sure is. Good job.
Yeah.
Right, bacteria are a big part of the nitrogen cycle. When you're looking at this chart, you'll see that there's bacteria here, bacteria there, right? They're in charge of converting that nitrogen into something usable. And spoilers for number 12. Anybody want to take a crack at number 12? What do nitrogen-fixing bacteria do?
I'll try.
Go for it.
No, what does it do? Let's see, what does it do? Doesn't it remove by plants and water changes?
Not quite. There's a better explanation of what bacteria
Put the
do.
question into like a more simple thing because I don't technically understand it.
Wait, doesn't it fix the nitrogen to make it usable? Wait, I thought
Yeah.
that's what you said. I could be
It's
wrong.
that simple. Does that make sense, Denise, or should I explain a little bit more?
Makes more sense now.
Yeah, could you explain a little bit more?
Yeah, so what happens is when, like, say when this fish dies, right, it's going to release a lot of dangerous things. So that's part of the reason why you don't eat, like, rotting meat on the side of the road, right? Like, if you hit a deer and you pick it up, take it home, and the meat starts decomposing, it's not good. Part of the reason is there's stuff growing on it. But the other part is because it's producing this ammonia. So if you ever smelled ammonia, it's that very, very, like, well, you know when you smell it, it has a very kind of sour, bitter, acrid kind of smell to it. What's happening is that that's poisonous. You know, we can't consume that. But there are bacteria that will take that chemical and they'll break it down into something that can be used. Because just like us, other plants and animals can't digest ammonia. We can't do it. But there are bacteria that can. So they take the ammonia and they basically convert it over a series of steps into something called a nitrate, which is then usable. Not necessarily the best thing for the environment, but it can be further decomposed and transformed into something that is usable by other organisms, either by returning nutrients to the soil or by, like it says here, removing it by plants and water. So for example, when the bacteria that are associated with plants do it, they're on the roots, right? So when the bacteria break down that nitrogen, it's returning it to the soil, which then helps the plant uptake water and basically helps the plant grow. And then again, spoilers number 13. Anybody want to guess where nitrogen-fixing bacteria live?
Plants. Oh wait, sorry, Brighton, you can answer it.
No, you can.
No, I talked like the whole class. You should answer.
Okay, fine. Okay, aren't they in the little bubbles on the root? I forgot what they're called.
Those, yeah, root nodules, very good.
Yeah.
So I didn't even go that specific. I just said on the roots of plants, right? Because they're returning a lot of that nitrogen to the soil. And it's important to remember, like this thing with the fish, right? They're not just in dirt, they're also in water. So mostly on the roots of plants, in soil, or aquatic environments. That's why there's also so much junk in the ocean, like carbon and nitrogen, is because of the bacteria that's there. Okay, so again, if you didn't finish, that's fine, because there's still lots of other questions to do. But I've helped you with a lot of them, and it shouldn't take you too long to get it finished later on. So we're going to talk about succession now. So I'm going to transfer over to the PowerPoint and make it very quick. Of course I say that, and then I gotta struggle to find it. There we go. Okay, so succession. Now, I don't expect you to recognize the word succession, but I do expect you to at least have some kind of familiarity with what the concept is. So, does anybody want to give a definition for what this is?
I can read it.
Go for it.
Natural gradual changes in types of species that live in an area can be primary or secondary.
And keep going.
The gradual replacement of one plant community by another through a natural process over time.
Thank you, Hugo. So what that means is that if you're looking outside, there's all these trees and grasses. It changes over time. It's not just the same always. Things have to grow, right? At one point, there wasn't a tree, there was a little seed, right? And before there was grass, there was probably dirt, and the grass came out of the dirt eventually. So what that process is called succession. So there's two different types. There's primary succession and secondary succession, which is what we're going to be mostly talking about right now. So primary succession begins in a place without any soil. So if you're thinking of a place without soil, that's going to be like the sides of volcanoes, maybe where there's been a landslide or flooding, basically where something really, really bad happened. When I think of primary succession, I think of like the very beginning of the earth, like before there was anything, or just volcanoes and lava and rock, and that's it, right? So eventually something had to happen, right? It wasn't like there was just volcanoes forever. Something started to grow and eventually became plants and trees. So it starts with the arrival of living things such as lichens that do not need soil to survive. These are called pioneer species. So you ever heard of like pioneers? Those are like the first ones on land, right? So like the pilgrims, they were pioneers, right? So what happens is you get a place that where there's nothing growing, like a bunch of lava rocks, and then eventually something starts to grow on top of it. So typically that's something called lichen. Lichen is like a moss. It's like if you ever seen like coral on the side of a boat, that's kind of like what it looks like. That's what lichen is, except it's on a rock, on land. This is what it kind of looks like. So it's this weird paper thin kind of growth that you see on rock. Sometimes it looks a little bubbly, but it's basically the first thing that grows. So again, this is primary succession. What's happening is this thing that's growing on the rock is going to start to break it down eventually to the point where it turns to dirt. Like you might have noticed sometimes when you pick up a rock on the ground, you hold it real tight, it crumbles, right? It turns to dust. That's probably because something started to grow on it and started to leach a lot of the moisture out of it. So primary succession, can somebody read this for me?
I can read it.
Soil starts to form as leaches, and the forces of weather and erosion help break down rocks into smaller pieces. When leachings die, they decompose, adding small amounts of organic matter to the rock to make soil.
Thank you. Very good. So I hope that makes sense, right? So a long time ago, you had these volcanoes. Those volcanoes erupted with lava. The lava cooled down, turned to rock, and then something started to grow on the rock. Those called, again, the lichen. And then what happens is the lichen breaks down those rocks into smaller pieces, and eventually it erodes and decomposes and turns into soil. That's where the dirt comes from. So a long time ago, there were rocks, like a billion years ago, in most of the places around here, right? Then something covered it, which is typically the lichen, sometimes moss. It broke it down into dirt, and that's where you get the dirt today. The decomposing material also served as nutrients for the soil. So there you go. That's what that looks like. You've got something breaking down rock. You got something growing out of it. Because again, this happens eventually. This happens several times. It's not just kind of one thing that happens once and that's it. It's a continual process. So primary succession. Simple plants like mosses and ferns can grow in the new soil. So once the lichen breaks down the rock and turns it into soil, something a little bit more hardy can come along. Something that needs soil to plant roots. What that means is that mosses and lichens, they don't have root systems, but things like ferns do. Simple plants die, adding more organic material. Soil layer thickens and grasses, wildflowers, and other plants begin to take over. So those simple plants that originally took over the lichen, those die as well, again adding more nutrients to the soil so that other things can start to grow. Then those plants die, add more nutrients to the soil, and then you can get shrubs and trees. So you're getting like a progression of smaller to bigger plants. And now insects, small birds, and mammals have begun to move in. That was once bare, what was once bare rock now supports a variety of life. It becomes an ecosystem. So the rock was broken down to soil, stuff started to grow in the soil, that stuff died and was replaced by new things, which died and replaced by new things until eventually you have a community. And then other animals can move in that start to feed and use that ecosystem. So let's see what that looks like. Share audio.
Ecosystems are shaped by biotic and abiotic factors. But before biotic factors like plants, animals, and fungi can become established, we need abiotic factors like sunlight, rainfall, and nutrients. And today, I'm here with ecologist Joe Mascaro, and he studies how ecosystems change over time. And Joe's going to help us understand how we can start with solid rock, and through biotic and abiotic factors, they can change this rock to support life. So let's track the stages of primary succession by visiting lava flows of different ages.
So, Suze, this is the earliest stage of succession, where the rock's been colonized by lichen and some small sword ferns. These guys will colonize lava right away, almost the day after it cools. And once they do, they'll begin the soil formation process. So they'll grow and they'll start to break apart the edges of these rocks, which are really friable and easy to break. And then the lichen will fix nitrogen from the atmosphere, and that will begin to build up soil on the surface of the rock.
Now let's move to the next stage of succession, one that's a bit older.
Well, Suze, this flow looks like the ecosystem has developed a bit more than the last flow. So you can see how there's so much more lichen than there was on the previous flow. It's almost like a carpet. And as the lichen grows, it's basically breaking up the surface of the rock and starting the soil formation process, which is really happening in earnest now compared to the previous flow.
The first plants that become established are early colonizers. Early colonizers have other characteristics. They're fast-growing, they need lots of light, and they're usually wind dispersed.
That's right. And there's basically two types of early colonizers we might see on a flow like this. There's some that have a symbiotic relationship with fungi, and so they're able to fix atmospheric nitrogen directly and use it immediately. And then there are plants that are just able to tolerate really low levels of nitrogen, like ohia.
Okay, off to the next stage. So here we have an even older flow.
So we're actually going to see quite a bit more soil here than we saw in earlier flows. And we've really got a lot of moss. So we're really starting to see the ohias come together, and we're getting much closer to a closed forest. We're not quite there yet, but you can see how much taller they are and thicker.
Off to the next flow. So this is what scientists would call mature forest. It's over 300 years old. It might be hard to imagine, but this whole area was once barren lava rock. Let's go check it out.
So, we're definitely in a later successional forest now, which means we're dealing mostly with tree species that are not wind dispersed. They typically have big fruits, maybe dispersed by animals. They're much slower growing, and of course, they tolerate shade. And as a result of all those features, they tend to need a lot more nutrients over time to grow.
Okay, so I hope that was informative. It's basically just showing you what it is that we're talking about, right? So you have a lava rock. That lava rock is broken down, which then becomes soil where things can grow. So whenever you see pictures of like Hawaii, and it doesn't make any sense how like this island in the middle of nowhere can have so much life, right? That's what it is that there's volcanoes that produce the lava, that produce the lava rocks that are broken down to form dirt. So that dirt is soil with all those organic nutrients where things can grow, and there you go. That's why you typically have those tropical islands so diverse, called biodiverse, is because it has so much activity compared to a place like where I'm from, Odessa, Texas, where it's just like a dust bowl, right? There's nothing there. There's no volcanoes. There's nothing. So there's nothing returning all those organic nutrients back to the soil. So eventually the soil turns to dirt and turns to dust, and there's just nothing there. Okay, now that was primary succession. Now we're moving on to secondary succession. So again, primary is the first stuff with the pioneer species and all that. Now we're talking about after all that has already happened. Can I get someone to read this? I think Casey was trying to read something last time, right?
Let's see what it says. Begin in a place that already has soil and
Okay.
was once the home of living organisms. Occurs faster and has different climate features than primary succession. Example, after forest fires.
Okay, thank you, Brandon. Casey, do you think you could give us like a summation of what he said?
If you want.
I do.
Okay. I was just gonna say it basically takes what was done in primary succession
Mm-hmm.
and or the environment from primary succession, and then it I was gonna say it does that process but faster, and then more animals and plants enter the ecosystem, or like the environment made during primary succession was like damaged, and so they fix the environment but faster.
Yeah, exactly. Very good.
Oh.
Thank you, Casey. So it's essentially kind of like, a baby growing into an adult, and the adult like cutting his finger, right? The cut on the finger can be healed after all the growth that's happened from baby to adulthood. The finger is fully formed now. It's not like you're going all the way back to like a baby finger. What happens is you cut your finger, your body's going to try and heal itself. It's building on top of the things that were already there. So it's not having to repeat that whole process. You're not having to regrow a whole finger. I mean, I guess if you cut your finger off, then it's gone. But I'm saying like if you just cut it. Not a perfect example, but I think you're hopefully understanding what I mean. Like let's take example like what's happening in California right now. So back in California, there used to be these big old forests, right? These big old trees. But something happened. Now there's a big fire and everything is burned down. That doesn't mean that it's going all the way back down to like the lava rock, right? There's no volcanoes that are just getting rid of everything. Once the fires have stopped burning, there's all this organic material that is now fertile that can provide the soil and everything for new plants to grow. It doesn't need to start all the way back at rocks, right? There's not rocks being broken down to turn to soil. The soil's already there. The trees are gone, that's true, but it can be reborn. It'll take time, but the groundwork is already there. So let's look at a video about that. Bloop, bloop.
Wildfire burned this area 2 weeks ago. This area burned 3 years ago by a fast-moving fire on a windy night. It's clear that the grasses were not killed by the blaze. Some of the broadleaf flowering plants became more abundant after the fire. The woody shrubs, such as sagebrush, did not fare so well. Many of the ponderosa pine were scorched, but most will survive and will recover. If we look closely, we can see the seedlings of shrubs beginning to recolonize the area. In a few years, the area will look much like it did before the fire. In this case, non-woody plants either survived the fire or reseeded it quickly from outside the area. They stabilize the place, protect it from erosion, and begin to rebuild the soil. Later, the woody plants take hold, achieving dominance over the pioneers that colonized the area after the fire. Eventually, the plant and animal community will resemble what was here before the fire. Nature's recovery from disturbances such as fire is an example of a process called secondary succession. If the disturbance is not too great, plants and the associated animals tend to replace themselves in a fairly predictable sequence, returning to a state similar to what was originally present. I'm Gene Gade of the University of Wyoming Cooperative.
So what he's saying there is that it might take some time, often a couple hundred years, but forests can regrow. Again, this is an example of secondary succession. And let me go back to our PowerPoint. So it's already building on what was already there, right? So there's big old forest fire. All the trees are gone, that's true, but there are still seedlings that are present in the dirt that can regrow. Again, it'll take a long time for it to get back to where it used to be, but it's not impossible. So here, as you can see in the diagram, this is what secondary succession looks like, right? There's no lava rocks, there's no moss or anything like that. It's just these little seedlings, like what we think of as weeds, right? They eventually grow into like shrubs, and those shrubs die and they're replaced by trees, and the trees die and are replaced by bigger trees, and so on and so forth. It's a much faster process. When we're talking about like breaking down rocks in the soil, it takes a billion years, right? It takes a long, long time. But here, the forest fires can be repopulated within sometimes a couple of months, maybe a couple of years, depending on the type of thing that was there before. I will say that if it's going to be like these big old trees, it's going to take probably a couple hundred years to get back to that. But not impossible. It's not going to take 1,000 years or anything. It's a fairly relatively quick process in the geologic time. What that means is that we kind of think of a year as a long time, right? But when it comes to nature, a year is not that long. It's very short, actually. Same thing you see here with the weeds and perennial weeds. These are years and years, right? So by the time it gets to a mature forest, here it says 150 years. So it can take a long time to go back to where it used to be. But that doesn't mean it's impossible, it just takes time. You'll notice that as it gets closer and closer to the beach, that you'll have less and less trees. Why do you think that is? Any guesses?
Wait, can you repeat the sentence, please?
Yeah, so you notice over here, you see lots of big trees. As you get closer to the ocean, there are no trees. Why do you think?
Oh.
Is it because that the sand isn't fertile enough?
Right. Number one, the sand isn't fertile. Very good, Saria. But also, there's not as much room, right? The trees need big old room, right, to grow roots and have like those deep roots. Whereas you get close to a beach, you're getting closer to sea level. There's not as much room for that plant to grow. Eventually, it's going to hit like bedrock, like the rock underneath. Like I don't know. When I was growing up, Odessa is not very. There's not as many hills. So if you went into the playground and started digging, eventually you're going to hit shale, which is like a type of like a really thick mud and then rock. So there's no way the roots can grow in that thick of dirt, right? It's really really compacted because there's nothing really growing there. And in fact, when we're in Odessa, where I'm from, there's a lot of petroleum deposits, right? A lot of oil. So oil needs that pressurized system to form. So trees want loose soil, right? They want this humus soil. It's kind of like what feels nice. It's not quite as loose as what you would find like a beach sand, but something where the roots can grow in a way that's not going to hinder itself, right? So you want a lot of area to grow big trees, whereas the beach is not going to have that for you. Plus, there's not as much nutrients there because the ocean probably takes away most of the nutrients as it goes out to sea. Very good. And climax community. So that's after primary succession, after secondary succession. This is at the very end of the process. That's when the hardwood forest is now done. Like all the trees are there, everything is perfect. There's lots of growth. That's a climax community, a stable group of plants and animals that is the end result of the succession process. Doesn't always mean big trees, right? Big trees don't grow everywhere. That could mean a lot of grass, could mean a lot of cacti if it's the desert. It just kind of depends on the ecosystem or the biome. I think it's kind of come into question recently, a lot of scientists, about whether kayaks community ever really exists because, nature's always changing, but that's a different discussion for a different time. And we're not going to look at that video because we don't need to. Okay, I'm running out of time. So I was going to give you some time to work on this. It doesn't seem like we have as much time. What I would rather you do, if you can, no, I don't want to waste time. We're going to jump right to the exit ticket. I want to make sure that you have plenty of time to do it. If you don't remember from yesterday, what you need to do is you need to go back into the assignments. There's a separate thing. It says ET 9.10. Let me make sure I write it down. ET 9.10 6. This will take you to a Google form. That is your exit ticket. They're formatted very similarly to our quizzes, which is, again, why I'm getting rid of our weekly quiz, because we'll be doing these exit tickets every day. It's important for you to get them done. Yesterday, we had about 45 respondents, which means we were missing about 20. So again, it's very important. Like I said, we are tracking them. They are for a grade. I'm taking daily grades from these exit tickets now. So make sure that you get this done by 3. You got a little less than 10 minutes to get that finished. It should be plenty of time. It's only about 5 or so questions. So again, you're headed to, actually, before I say it, someone else say it. Someone tell us what it is that we're about to do right now.
We're gonna do the exit ticket.
How do you get there?
You go to the assignments and you go to the ET 9.10 succession.
Thank you. And once you're finished, once you've completed the quiz, not the quiz, once you've completed the exit ticket, make sure that you mark done, that you turn in the assignment when you're finished. That way Teams knows it's done and you don't have to worry about that counting against you. So again, make sure that you go to that link, take the exit ticket, then go back to Teams, turn it in, and then you're finished. I'll be monitoring the form so that I can let y'all be released, same as Carpio did if y'all were in geometry before this. As I'm seeing responses come in, I will call your name. I would highly recommend that you use that time to work on your guided practice from earlier with the cycles, because we'll do some more of that tomorrow. So you got 10 minutes, more or less. Good luck.
I have a question.
Go for it.
Since we're not doing weekly quizzes anymore, are we still gonna have a quiz tomorrow?
No, good question. So I decided to go ahead and not have our quiz tomorrow, so we'll be utilizing our time better. We will have an exit ticket because, again, we're doing exit tickets every day. So if anything, think of that as your quiz. So it's still important for you to be reading your CK through 12. I'll still sprinkle in those questions every now and then. But no, there is not going to be any quiz separate from your exit ticket going forward. Unless y'all are being bad, and I feel like y'all need one. But I don't anticipate that being a problem.
Oh, thank you.
You're welcome.
Sir,
Mm-hmm.
can I redo my exit ticket?
Unfortunately, you cannot redo it. I had to ask permission, and they said that your first submission is what counts. Why? What happened?
Made a few mistakes.
Like dumb mistakes or intentional mistakes?
Dumb ones.
Um,
I'm gonna be honest. I kind of did one too.
Send me a Teams message and I'll take a look at it. Okay, so I've got responses coming in. Again, there's no intervention time. There's no SEL lesson and den. So once I've gotten your submission, as far as I'm concerned, you are good to go. I would highly recommend that you use your time wisely and that you even stay logged on for a little bit so that you can finish your guided practice. But this is your last class for the day, and if you have something else you need to do, then I would tell you to go do that. So, Jacob Carrasco, I have your response. Thank you. Dominic De Leon, I got you. Desmond, got your response. Thank you. Avery. Also, Avery, I'm curious. On all of our official stuff, it spells your name with an O, but whenever you turn stuff in, you spell it with an E. Is it because we're wrong, or should I accuse you of not spelling your own name right?
What happened?
Avery, it says Avery, like that's what you put, but on our system, it's Avory.
Oh, it's not me.
It's Desmond. I was talking
Yeah,
to Avery.
it's okay.
Mr. Martinez,
Uh-huh.
do we have to complete the carbon cycle practice?
The one from Tuesday?
Oh no, the nitrogen and carbon cycle practice today.
Yeah. So if you didn't get that finished, that's for homework.
Okay.
Okay, so Avery, got you. Michael, I got you. McCracken. Jimena, I got you. Thank you. Ayla, I got you. Hugo, got you. Terrell, got you. Eileen, you're good to go. Brighton, you're good to go. Grace, good to go. Shakira, good to go. Janae, thank you. Brighton, I think I already called you. Bye, Grace. Hamza, got you. Noor, got you. Zaria, got you. Miguel Alvarado, I got you. Casey, got you. Amian, I got you. Giselle, got you, good job. Faye, got you. Melanie, got you. Kaylin, I got yours. Caleb, I got yours. Ayana, got yours. Caden Dunn, got yours. Bye, Faye. If I didn't tell you already, good job today. All of you did such a wonderful job. Thank you all for participating. Thank you for doing your best. Again, the X ticket is due at 3, so make sure that you get this finished before you leave.
Goodbye, sir.
Bye.
Have a nice day.
You too. Have a nice day.
Have a wonderful, extraordinary
No.
day.
Oh, Lord.
Bye, Mr. Raymond.
Have
Have a nice rest of the day.
It's
Bye.
Mr. Martinez.
Oh,
Raymond
bye,
is his first name.
Buchanan.
You go.
Bye, Mr. Martinez.
Bye, Mr.
Bye.
Martinez.
Bye.
Bye.
Bye, Kaylin. I got yours, Josiah. Thank you.
It won't let me mute myself. You know what? I'm just going to leave.
If you don't want to leave, I can always mute you. I think she left. That's fine. I got Ayla. I haven't gotten yours yet, Lauren. Cameron Dixon. Oh, Lauren, there you are. You're good to go. Miguel Gallegos. Brandon, I got you. Gila, you're good to go. Hannah, I don't remember calling your name. I don't think I've gotten to yours yet. No, I haven't got yours, Hannah. Natalie, I got you. Clint, I got you. Thank you, Janae, I got it. Those of you still working, got a little less than 5 minutes left for 3 o'clock. I'll go ahead and stop this timer because it's already 2:55. Unfortunately, they are not allowing us for you to redo them. I will make an exception for corrections. I would think I will accept corrections, which I'll talk about later. It's okay, Gila, we all make mistakes. Got 3 minutes left. Those of you still working, I'm still missing about 15. Yeah, Hannah, I'm not sure what happened. I didn't get it. If you remember your answers, I think it might be worth it to try and resubmit it. Okay, Alex, the exit ticket is posted in assignments. It's covering the information that we talked about today with succession. It's about 5 questions, I think. So what you do is you click on the assignment. There's a link that says exit ticket. It'll take you to a form, and you're just filling out the form. Brian, I got you. Thank you.
I turned in my stuff.
Okay, thank you. Oh, Hannah, there you go. I got yours now. Alan, I got yours. Thank you. Now, I know a lot of you really want to be the best, so you are submitting multiple attempts, which, again, I can see. Whenever I put in the grades for these, I do them in the order they were received. So I'm taking your first submission. So unless it was like, 5 seconds and you missed all of them, then, I might accept that. But for the most part, I'm putting in whatever I see first. So if you want to retake it, try and get a better score. Totally, I applaud your incentive, but know that I'm only taking your first attempt. I got about 1 more minute before 3. Again, I'm still missing about 15. Which tracks, I got about 20 people left here. So again, make sure that you're turning in this exit ticket before you leave. It is 3 o'clock. I noticed that some of y'all turned it in yesterday after 3, which is okay, but they are due at 3. So the latest I'll take it is like 3:05. Thank you, Destiny, I got it. Thank you, Karina, I got it. Now we do have a meeting at 3 that I need to get to, so I'll log off here pretty soon. But please know that you have to get this done. The grades are going into the grade book. You might have noticed I already put the one in from yesterday. So yesterday's is already in the grade book. This one will go in probably tomorrow. Thank you, Sherivan. Thank you, Eddie. Thank you, Hadassah. Thank you, Alex. Thank you, Kadarian. Good job. Thank you, Angel. Yeah, I got it, Alex. You're good to go. Bye. Oh, I'm sorry. I didn't see what you said, Sheridan. What problem do we have? Okay, I gotta get to my meeting. Make sure if you haven't yet that you do turn in your exit ticket. Yeah, what do you, Sheridan, is there something you need? I hear you, but I don't know what you need. Okay, well, since no one is answering or saying anything, I'm going to go ahead and end the call. I'm going to go to my meeting. It's okay. We'll be able to do corrections later. So if there's nothing else, then I guess I will see you guys later. Oh, I should stop recording.